We're looking at homework from section 4.2 today. This is question number 9. Let's read the question. 32% of adults favor the use of unmanned drones by police agencies. 12 U.S. adults are randomly selected. Find the probability that the number of U.S. adults who favor the use of unmanned drones by police agencies is A, exactly 3, B, at least 4, C, less than 8. So, this is a binomial because either a person favors the use of unmanned drones or they don't. They either support the drone use or not. So that gives us our two possibilities. We need our value of n. N is the number of individuals that we are asking. So we're asking 12 U.S. adults. So our n is 12. P is the probability that we find one that favors the use of unmanned drones, and that's going to be 0.32. The binomial probability formula is P of x equals NCX, P to the x, Q to the n minus x. So besides the n and the p, we also need the values for q and x. Remember, q is always 1 minus p, so 1 minus 0.32 is 0.68. And x is the number of successes that you're looking for. In part A, we're looking for 3 successes. So we're looking for probability of 3 equals 12c3, 0.32 to the third, 0.68 to the 12 minus 3. We know that 12c3 is equal to 220, and the 12 minus 3 becomes the 9th power on the 0.68. When we enter this into our calculator, we end up with 0.2241056626, rounded to 3 decimal places is 0.224. So that's your answer to part A. There's a built-in function on the calculator that can help you do part A as well. It's called the Binomial Pdf Formula. If we had used Binomial PDF, then what we would do is we would put Binomial PDF 12, 0.32, 3. The 12 is the n, the 0.32 is the p, the 3 is the x value. Notice we don't have to enter the q because the calculator computes that value for us. Q is 1 minus p, so once you tell the calculator the value of p, it can automatically calculate q. It doesn't need an extra input for that. So if you enter this into your calculator, you get the exact same answer, 0.224. Let's look at part B. In part B, we're looking for the probability that the x value is greater than or equal to 4. So because the value of n was 12, x greater than or equal to 4 would end up being 4, 5, 6, 7, 8, 9, 10, 11, and 12. Those probabilities all added together. That means you would have to do the process from part A 9 times. You would have to enter the 4, you'd have to enter the 5 and the 6, and keep going over and over until you get to 12, and then add up all those answers. That's a lot of work. So we're going to turn to technology. We're going to use the TI-83 or TI-84 graphing calculator because it has a built-in function that's going to help us out quite a bit. That built-in function is called the Binomial Cdf function. So what the Binomial Cdf function does is it adds probabilities. It always starts when x equals 0. And then it's going to add x equals 1, and then x equals 2. And you have to tell it where to stop. So the first thing we need to realize is because we're looking at x greater than or equal to 4, this sum doesn't start at 0. And the Binomial CDF specifically adds things that start at 0. So that means we're going to have to do a subtraction. It's actually a complement for what we're going to put in. Remember, all the probabilities in a sample space add up to 1. So what we're going to do, because we don't want to include the values from 0 to 3, is that is going to be the binomial CDF that we actually find on the calculator. And then we're going to subtract that from 1. And by subtracting that from 1, that's going to leave us with the probability of 4 and 5 and 6 all the way up to 12. So this is going to be 1 minus the binomial CDF of 12, 0.32, 3. So we're getting rid of the values from 0 to 3, which leave us the values from 4 to 12. And when we plug that into the calculator, we get 0.5680534416. Rounded to 3 decimal places is 0.568. How about part C? Part C says, let's find the probability that x is less than 8. So again, we would have to do the process from part A 8 different times, because x being less than 8 would be all the values from 0 through 7 being added together. Probability of 0, 1, 2, 3, 4, 5, 6, and 7 all added together. This time the sum does include 0. So we're going to get lucky and be able to use that Binomial Cdf formula on the TI-8384 graphing calculator. But we don't have to do a subtraction this time because we actually have 0 in our sum. All we're going to do is tell it where to stop, right? So we're going to have to input the values and tell it the stopping value, the terminating value that we want for this particular binomial CDF. And when x is less than 8, the last value we want plugged in is 7. So that's what we have to include, the values from 0 to 7, which is binomial CDF 12, 0.32, 7. And if we enter that into our calculator, we end up with 0.9855549702, rounded to 3 decimal places is 0.986. And that's your answer.